So in the previous versions of MetaPath, we had data represented in four layers or four types of data. The first type was chemicals layer, when you show the structure, chemical names, regulatory identifiers. The second layer is the layer that represents the transformations. It includes the pair, parent and metabolite, possible enzymes, and hierarchy of the observed transformation, how they organize in trees. The third layer is the experimental layer. It is the more rich layer with data, because it represents the specific of the corresponding tests. For example, species, experimental systems, doses, and so on. And fourth, we have associations also between the transformations and experimental details. A few years ago, we had a project that was funded by Unilever that allowed us to implement this kinetics data, but this functionality for the whole time remained in the private domain. Recently, EFSA funded a project that make it possible all these functionalities to be migrated from the private to public domain, and this version is already ready and just waits for approval from EFSA to be available to the public. Actually, kinetic data provide information about the kinetics of the metabolic transformations. This layer could include either values like Km, Vmax, clearance, or time series, which actually are quantities of parents or metabolites as a function of time. Also, depending on the type of the kinetic experiment, we may have two different types of values. For in vitro experiments, we have Km, Vmax, clearance. And for in vivo experiments, we have this area under curve, the time switches corresponding to the area under curve, etc. And now, what is the connection between the kinetic data and the other layers of data? First, kinetic data is associated with a chemical, but also kinetic data is associated with the experimental details, which are actually represented by the treatment groups. So, for any set of kinetic data, must be associated with a combination between a metabolite and the treatment group. I will show you just in a minute how this is implemented. Now I will skip here this part of the presentation because I prefer to show you in the program. Here we have a database that has such kinetic data, and you could spot easily where such a data is present by these marks. KD means that we have kinetic data here for this metabolite. Here we have time series, or we may have a case when we have end kinetic data and time series for the same metabolite. This information here is can be accessed easily here via this information button. You can go here to the treatment groups, and if the treatment group has such a time series, there is a tab here that represents this data. If the treatment group has no such information, the just disappears. If you want to edit this information, you should go to the window that edits the structures, and here we have a new type, which is for kinetic data. It lists all treatment groups in the map, and when you enter data here, you enter it for the combination between this treatment group and the chemical that is being edited already. Here in the kinetic values, you can switch between in vitro and in vivo experiments. You can see that the values are changing here. And we also provide a field which is calculated clearance based on Km and Vmax values. This is different from the clearance that may be found in the literature. It has a special field for it. And calculated clearance we provided just for comparison purposes. Now, let's here make a search based on the kinetic data. You can see here that we have a special tab. The values which are related to the kinetic data is separated into 3 sections. The first one is for the fields which are common for the in vitro and in vivo experiments, and the second and the third is for the values which are only in vitro or only in vivo experiments. Now I will make a search for Km because we have such type of data. I will just enter here a range and make a search, and you will see that we have a lot of chemicals that mean this search criteria. We also may use the specifics of the experiments in order to make some more narrow searches. For example, I may enter a new clause for the experimental system. I can make a combination here, and you will see that here we have a smaller number of chemicals. And again, if I click on this metabolites, the system just goes on them. And if we check here the Km value, you will see that it is in the range that we put in the search clause. So this was the example on kinetic data, and practically I am done with my presentation. As I said, it will be soon available to the public. If you have some questions, just ask me.